Today is April 20th, 2025. Data mining review. First, data mining, what we use is the linear algebra calculus optimization method. And for statistics, what we are using is P distribution, which is continuous distribution, probability density function with gamma function exists, and chi-square distribution. And for data set, what we are going to use is basically we can decide between input variable and target variable. For variables, there can be numerical and categorical, and then for numerical, there can be continuous and discrete. For categorical, there can be ordinal and nominal. For later, you will calculate correlations and so on. For correlation, there is Pearson correlation, but it's also there is correlation that you can calculate the random correlation and rank correlation. For category. There's two correlations that I will discuss with you later. So when you want to understand data, you will understand data types, and after that, you need to handle missing values. Missing values and calculate outliers. When you calculate outliers, you usually do calculate z-score, and for each point of z-score, if for each point of z-score, you will see in which point of z-score you will set as a threshold of outlier. My question is it like actually same as hypothesis testing? And when you reject null hypothesis and accept alternative hypothesis, you can use by using by setting significance level set check the p-value, or you can also use calculating value. So I was thinking about actually it can be same concept, z-value of outlier, and calculating the test statistics to compare with some level. And after that, for calculating outlier, there is g value, but there is also what you can use is interquantile range, which is calculating Q1 and Q3 and Q2. Q3 is upper quantile and Q1 is lower quantile. So if it goes out of certain value, we usually multiply 1.5 of Q3 or 3 multiply Q3. And we can also visualize this result with for correlation, we can use for interquartile range, you can use this kind of I forgot the name, and you can also use scatter plot to check correlation or check other of the statistics. So basically, when you checking statistics, you're checking outlier and also kurtosis and skewness. When you're calculating skewness, what you are doing is G score, you will calculate it as X minus mu over sigma 3 expectation. You will use that one for G score. This skewness. For samplers, you use this little bit different. You use this one, 1 over n, x sigma xi minus x bar squared. And in denominator, there is n minus 1, xi minus x bar squared 3 over 2. And if it is positive skewness, it will be mode, median, mean. And if it's negative skewness, it will be changes. It will be opposite. And for kurtosis, it's checking healthiness. You can check, there's Fisher kurtosis, which is calculating this one and -3, and we're checking whether it is positive number or negative number. So when you calculate, now is visualization. When you checking distribution, we can use histogram for distribution. So you can check how it is symmetric or whether it is different shape. And you can also use box plot, which is you can notice easily about distribution, IQR ranges. And for correlation, what you are using is R equals to sigma xi minus x bar, yi minus y bar, and square root xi minus x bar square, y minus y bar square. And it's actually this is R, and this is similar with when you're later calculating beta 1 hat. Well, I thought it's kind of similar because nominator is same, and in denominator it's a bit different. So I thought there is kind of relationship between R and beta 1 hat. And yeah, for Spearman rank correlation, which is calculating rank, for each of the variables there will be rank. Then you will calculate between each others and square. And using it, we will calculate 6 over sigma di square over sample number square minus 1 is Spearman rank correlation. And for knedal'stau, which is for categorical variable checking each pair, it is discordant or not non-discordant. So you can check the kind of correlation by it. Yeah, and for scatter plot and pair plot, you can use it for checking correlations, and you can transforming the variable by one-hot encoding or min-max scaling or robust scaling, which is when you're making G-score, you use different values. And we will continue with supervised linear regression. If I just go with the beginning, I was interested that when you what supervised learning do, I will continue, but it is minimizing real value and predicted value, and it will be sigma EI scale, and it can be represented as vectors. And this whole equation we can represent as matrix. And when you calculate DI and DI scale, it will be like connected to MS sorting. So actually, I'm curious about why degree of freedom comes out like this. And this was each of the correlation. I will continue later. Thank you.